Hello everyone, my name is Takafumi Yoshida. Today, I would like to share information on one project, assessment of the distribution of tidal flood in the Northwest Pacific region, implemented by NAPAP-CELAC. At first, I would like to introduce what is NAPAP. NAPAP is one of the regional C programs of UNEP. Regional C program aim to protect marine environment with related countries. NAPAP's target area is the Northwest Pacific region and China, Japan, Korea, and Russia. 4 countries are member states of the NAPAP. Based on the decision of member states, activities are implemented by 4 regional activity centers. CELAC I belong to is one of the 4 regional activity centers, and our responsibility is development of special monitoring tool and coastal environmental assessment with developed tools. Biodiversity conservation is one of the high priority environmental issues in NAPAP, and CELAC implements activities on biodiversity conservation in this decade. As you know, in coastal area of China, Japan, and Korea, there are many tidal floods. Tidal floods are important coastal habitat for marine biodiversity conservation. In the NAPAP member states, several marine species living in tidal floods are selected as endangered species, including migratory birds and benthic marine species. However, many tidal floods have been lost by the past coastal development. To conserve marine biodiversity, protection and management of tidal floods are important. In NAPAP, protection of coastal habitat is one of the high priority topics. Several tidal floods are selected as Ramsar Convention site and also marine protected area in the NAPAP member states. Therefore, to understand the current distribution and historical change of tidal floods are contribute to marine biodiversity conservation in the NAPAP region. However, there are some problems to assess the status of tidal flood. Major problem is difficulties of regular monitoring. To monitor tidal floods, researchers should visit each site and monitor. For in situ monitoring, time and human power are required. Therefore, it is difficult to conduct monitoring every year. For the difficulties of regular monitoring, available information of the current and past distribution of tidal floods in the NAPAP region is quite limited. However, one scientific group developed very useful monitoring tool, namely Global Intertidal Change, GIC. Leading scientist of GIC is Dr. Nicholas Murray of James Cook University. GIC monitors tidal flood distribution using satellite images, and quantitative information of tidal flood can be provided. Visible information on global distribution of tidal flood is available through their Google Earth Engine application. In GIC, tidal floods were detected using over 700,000 satellite images of Landsat. Landsat satellite images are available from 1980s, so historical change of distribution in past 30 years can be provided using this tool. Analysis was conducted in Google Earth Engine, a cloud-based analysis platform. Tidal floods are detected by machine learning, random forest classification algorithms. Using global scale bathymetry data and multiple Landsat-derived spectral reflectance variables, each pixel is classified into land, water, and tidal flood. This mapping tool is very useful for understanding the distribution of tidal flood in the Northwest Pacific region in place of in-situ monitoring. However, GIC have several limitations to use in our region. GIC was developed for global mapping, so regional characteristics are not reflected in this tool. In the Northwest Pacific region, 2-bit water is distributed in coastal area. In addition, difference of high tide and low tide is big in southern parts. On the other hand, it is very small in the northern part of our region. Monitoring by satellite is very useful, but the cloud influences the detection of distribution of tidal floods. So the number of available satellite images for machine learning are limited. The biggest problem is limitation of training data. GIC detects tidal flood by machine learning. For machine learning, much training data, information on real distribution is necessary. However, as I mentioned, time series data on tidal flood is quite limited. Finally, in the northern Pacific region, aquaculture is very active, and there are many aquaculture ponds in coastal area. They cause misdetection of tidal flood. To get high accuracy distribution map, we have to design the GIC for the Northwest Pacific region. This slide shows one example of differences between GIC and real distribution. In left image, in Seto Inland Sea, Japan, red area shows tidal flood detected by GIC. Pink area are real distribution, and yellow area are misdetected by GIC. As you can see, tidal flood by GIC are underestimated, and riverside and landfill areas are misdetected by GIC. Right table shows the summary of comparison of GIC and real distribution of 4 countries. In Japan and Korea, GIC underestimate. On the other hand, in China and Russia, GIC overestimates tidal floods. The reason why overestimate is aquaculture pond in China and lack of training data in Russia. To use GIC for the mapping of tidal flood in the NAPAP region, CIRAC implement one project. Objective of this project is to redesign the GIC to the regional GIC for the NAPAP region and to map the distribution of tidal flood using regional GIC. As I mentioned, GIC is machine learning. To increase accuracy of the detection of tidal flood, large amount of training data is necessary. So we asked member states to provide information on real distribution of tidal flood in each country. Provided data was used as training data, and the GIC was redesigned for the NAPAP region. The first map of tidal flood in the NAPAP region was developed, and historical distribution from 1998 is available. As shown in table, detection ratio of tidal flood by regional GIC was improved from original version. However, area of tidal floods is still underestimated, and misdetection is still happening. Left table shows misdetection ratio by original GIC, and right table shows the misdetection ratio by regional GIC. Misdetection in Japan and Korea are improved dramatically. However, small number of misdetections are still remain. To produce more high accuracy map in the NAPOP region, we continue improvement of the regional GIC. The final distribution map will be opened in next year. CIRAC also monitors seagrass bed distribution using remote sensing techniques. Seagrass bed is also important coastal habitat in the NAPOP region. CIRAC has already developed a cloud-based information system, Map Seagrass. We plan to provide information on coastal habitat in the NAPOP region with this platform in near future. If you are interested in such products, please visit our website. This is the final slide. I would like to propose to use remote sensing techniques for monitoring of essential biodiversity variables. Remote sensing has many limitations, but it is more benefit for regional and global monitoring. And a cloud-based platform, such as Google Earth Engine, is very useful tool for providing the monitoring result to users. We have to provide more easy understandable information to stakeholders. Visualization of monitoring result is one of the methods for easy understanding. Google Earth Engine can help to analyze big data, so it is very useful too. It is glad my suggestion is useful for your discussion. Thank you for your attention.